see him go, twisting the night away.
Hey everyone, welcome to today's lesson about solving exponential equations. We've got no new vocabulary for today, so we're just going to dive right in. When an exponential equation has the same base on each side, then the exponents must be equal. So today when we're solving equations, the goal will be to write both sides of equations so they have the same base. When the bases are the same, we can look at the exponents to then solve the equation. Let's go ahead and look at example number 1. I see that 3 to the x equals 81. My goal is to write 81 as a power with base 3. So I'm going to write 3 to the x equals 3, and 3 to the what power equals 81. You can use your exponent sheet and see that 3 to the 4th power is equal to 81. Now that I've written both sides with the same base, I can look at the exponents. This tells me now that x must equal 4.
That was easy.
Alright, moving on. I have 4 to the x, which is equal to 1 over 16. I need to write 1 over 16 as a power of base 4. Now, since it's 1 over 16, I know that my exponent is going to be negative. Now, 4 to what power gives you 16? And that would be to the 2nd power. So I can see now that x has to be the same as negative 2. So x equals negative 2. All right, looking at part C, on the left side, I have a power with base 5, so I need to write the right side of the equation as a power of base 5. So 5 to the x minus 2 is equal to 5 to what power? Looking at the exponent sheet, I can see that 5 to the 4th power is 625. That now tells me that x minus 2 has to be equal to 4. Okay, since the bases are the same, the exponents have to be the same. If I solve for x, I add 2 to both sides, and now x is equal to 6. Very nice. Let's look at example number 2, and we've got an application problem. Oh, excuse me there. Example number 2. The function b of x equals 3 to the power of x minus 1 models the number of bacteria in a culture after x days. So x represents the number of days. According to the model, after how many days will there be 729 bacteria? So we are solving for the number of days, which is x. I know that there are 729 bacteria, so I go ahead and plug that into the model. 729 equals 3 to the x plus 1. Now this problem looks very similar to the ones up above in example 1. I need to rewrite 729 as a power of base 3. Look at your exponent sheet and you can see that 729 as a power of base 3 is 3 to the 6th power. 3 to the 6th is equal to 3 to the x plus 1. Since my bases are the same, now the exponents must be the same, so 6 equals x plus 1. To solve, I subtract 1 on both sides, and x equals 5. All right, moving on, folks. We've got one more example to try. In this example, we're going to solve by graphing. In order to solve by graphing, I'm going to graph both sides of the equation. I'm going to graph 16. I'm going to graph 2 to the x plus 1. Okay, so I'm going to say y equals 16 and y equals 2 to the x plus 1. Let's go ahead and label our graph along the x-axis. We don't need to go up too high, so we can say 1, 2, 3, 4. I'm labeling every other line here. And then on the y-axis, we have to make sure we get all the way up to 16. So I'm going to go ahead and label by, let's go by just ones. and I'll mark every fifth line. 6, 7, 8, 9, 10. Okay. First, graphing y equals 16, we know that that is a horizontal line right at 16. So I'm going to go ahead and put a line through there. Next, I need to graph the function y equals 2 to the x plus 1. So I'm going to go ahead and create a table. My x values, you can see I've only labeled positive values, so go ahead and just start with positive values. That's 0, 1, 2, 3, 4. And my goal here is to see where my two graphs intersect. Where my graphs intersect will be the solution to this equation. So if I plug in 0 for x, I get 2 to the first power, which is 2. If I plug in 1, I get 2 to the second power, which is 4. If I plug in 2, I get 2 to the third power, which is 8. If I plug in 3, I get 2 to the fourth power, which is 16. And then 2 to the fifth power is 32. Let's go over to the graph, and I'll label these points. So if I go over 0 up 2, I go over 1 up 4. Well, it looks like my graph is labeled incorrectly there. I apologize. Over 2 up 8. I'm going to go over 3 up 16. And if you see right here, that's where I intersect with my graph. So I'm going to go ahead and draw this line through here. It's not perfect, I apologize. But what is perfect is that we can see the intersection. And these two graphs intersect at the point 3, 16. We were trying to solve for x, so x equals 3. Okay, again, so when I'm graphing, I'm going to graph both lines, and I'm looking for that intersection point. All right, now it's your turn. I want you to try the self-quiz and then check your answers. All right, on the self-quiz, you should have rewritten the right side of the equation as a power of base 4. So you see it's 4 to the x equals 4 to the negative 3. So x equals negative 3. In question number 2, you had to rewrite the right side of the equation as a power of base 9. So you get 9 to the x minus 2 equals 9 to the third. So x minus 2 equals 3, and x equals 5. In question number 3, I've got a model for the members in an online social networking site after x days. So x is measuring the number of days. It says after how many days will there be 1,296 members? Well, I'm going to plug in 1,296 for the number of members, and I'm going to be solving for days, which is x. So 6 to the x minus 3. I need to rewrite the left side so it's a power of base 6. We know that because of our exponent sheet, we can see that 1296 is 6 to the fourth, which is equal to 6 to the x minus 3. Now 4 equals x minus 3, and x equals 7. All right, the last problem, you had to use a graph to solve 81 equals 3 to the x minus 1. You'll remember from up above, you had to graph two lines, so I'm going to be graphing the line y equals 81 and the line y equals 3 to the x minus 1. Let's go ahead and label our graph. I'm going to go up by, I'm going to label by tens. Hopefully I do a little bit better job than I did up above. 50, 60, 70, 80, and 90. Then across the x-axis, we'll go ahead and do every other mark. Okay. First things first, I want to graph that 81. So I'm going to go over here just above 80, and we'll go straight across. Now, to graph 3 to the x minus 1, I'm going to make myself a nice little table, x and y values. Let's start at 1, 2, 3, 4, and 5. Now, if you decide to start yours at 0, that's fine. If you decide to start at -1, that's fine. your tables can be a little bit different. You just have to make sure you go up high enough to where you can see the intersection point. So if I plug in 1, I get 3 to the 0, and we all know anything to the 0 power is 1. If I plug in 2, I get 3. If I plug in 3, I get 3 squared, which is 9. If I plug in 4, I get 3 to the 3rd power, which is 27. And if I plug in 5, I get 3 to the 4th power, which is 81. We can see now that's what we wanted. We wanted to get up to 81. So let me go ahead and graph, make sure they intersect just where I want them to. So if I go over 1, up 1, over 2, up 3, over 3, up 9, over 4, up 27. I'm really starting to increase quickly now. And over 5, up 81. We can see very nicely that the graph intersects right here at 581. So the solution is x equals 5. There you have it, folks. Hope you learned a whole bunch about solving exponential equations. Good luck on the practice for tonight.